Hi everyone. Today I'll be speaking on projector and projection onto a line and numerical linear algebra. My name is Isaac. I'm on the table with you. Let's get started. I'll be speaking on projection onto a line, and the second one we'll be looking at creating a projector or a projection matrix to do the same thing as the first one. So given from the graph here, assuming we want to project our V onto our U, such that the distance between our V onto our U should be the shortest distance from V onto our U. And then projection of V onto our U is like casting a shadow of V onto our U. So to get our projection onto of V onto U, we consider getting a certain scalar times what U, such that the difference between our V and then the projection of V minus U should give us what the projection orthogonal projection vector here. So we'll look at that one into details. So looking at the orthogonal projection onto a line, suppose we have a line UL which spans U, and V is projected onto the line U. Then we are saying that there exists a certain scalar C belonging to a set of real numbers such that the projection of V onto our L is the same as what a certain scalar C times what our U. And then the orthogonal projection vector is the same as what V minus what the projection of V onto our L. So to get the scalar C, then since we have the vector here times the vector here, okay, since it's orthogonal, minus what the dot product should give us what 0. So we consider multiplying this one times this, which gives us rise to this, and it's the same as what C times what U over the times the whole of this, which is also equal to 0. Then we move a step further. We rewrite equation 1 as equation 2, and then bring the whole of this term to the right hand side, which gives us equation 3. Obtaining equation 3, since C is a scalar, we then cancel out, then the C's cancel out, leaving what U dot V equal to what our C times what U dot U. So to make C the subject, we divide by U dot U, which gives rise to the whole of this. So our projection, therefore our projection of V onto our L is basically what the scalar that we have here times what U. Now let's look at what a typical example under this. So given a vector V to be equal to this and a vector U to be equal to this, and our L is the span by U. Our L is being spanned by U. Then we want to compute the projection of V onto our L, and the projection of orthogonal projection of V onto our L. To find the projection of our V onto our L, then we look at a scalar product, okay, which is what U dot V. But what we have here is U dot V over what U dot U, the inner product of it, then times what our U, which gives rise to what the whole of this. And this is our projection. This is our projection vector of V onto our L. And to get the orthogonal projection of V onto our L is, like we have seen it already, V is equal to V minus what the projection of V onto our L, which is our V vector minus what the projection vector. And then you eventually have what the whole of this. Now, coming to the projection matrix, we want to generate a matrix. Okay, generate a matrix P such that our P is known to be a projector, and this projector, the projector P is the same as what P squared. As when you square this P, which will still give us back our P, and the P transpose should be the same as what our P. And this P matrix is known to be the idempotent matrix. So to find our matrix P, we find the outer product of U, that is U dot U times what U transpose, over the inner product U transpose over U. And to get the projection of V onto our L, then we say is the projection matrix P, the projection matrix P times our vector V, which gives rise to the whole of this, as the outer product over the inner product times what our vector V, and the orthogonal projection of V onto our L is V minus what the whole of this, P times what V, which gives rise to the whole of this. So let's look at an example to see if we'll get the same answer as the first one that we have seen. So considering the same example that we have our vector V and our vector U, we have to compute the projection of V onto our L and the orthogonal projection of V onto our L. So to get our P, we already know it to be the outer product over the inner product, which our outer product happens to be this matrix, and our inner product happens to be a scalar, which is 3. So to get a projection matrix P, then we divide the scalar by the outer product, which eventually we happen to obtain our P matrix to be this. Now, obtaining the P matrix, we now want to look at the projection of V onto our L, that is P times what V. So the matrix P times what the matrix times the vector V help us to arrive at this, which is the same as what we have seen in the previous example. And then the orthogonal projection, then our orthogonal projection of V onto our L is V minus the projection of V onto our L, which we know our V to be this, and the projection, which is the whole of this one minus the whole of this one. So eventually we happen to obtain the same solution. So this one tells us that to get a projection onto a line, there are several ways to do that, and we have seen 2 of them, which give us the same answer, or which give us the same solution. So coming to this point, we have now come to the end of this tutorial, and I would like you to like, comment, and subscribe to this channel. Thank you.